Hello everyone, and welcome back to the Fluctus Channel. Self-propelled howitzers became a core component of U.S. Army firepower during World War II. Early artillery pieces were towed into battle, limiting their mobility and exposing crews to enemy fire. To solve this, the U.S. began mounting howitzers on tracked chassis, creating mobile, armored artillery capable of keeping pace with advancing forces. After the war, the U.S. modernized its fleet, introducing the M52 and later the M109 series in the 1960s. The M109 remains the backbone of U.S. mechanized artillery. Its 155mm gun and rotating turret deliver firepower with precision.
Target plan safe. 1 round. Do not load. Shell HE. Fuse time. Mike 767 Alpha 1. Fuse time.
While decades of upgrades have kept it relevant on modern battlefields, today's M109 Paladin comes with advanced suspension, digital navigation, and automated systems, ensuring American artillery stays mobile, accurate, and lethal. The M109A7 Paladin is the U.S. Army's premier 155mm self-propelled howitzer, delivering powerful, rapid artillery support with modern digital precision. Equipped with an automated fire control system, it can fire GPS-guided Excalibur rounds out to 40 km with pinpoint accuracy. Its upgraded chassis and suspension increase mobility, allowing it to keep pace with armored units across rugged terrain. The Paladin can unleash 4 rounds per minute in burst mode and is protected by improved armor against small arms, shrapnel, and IED threats. With advanced navigation, secure communications, and faster shoot and scoot capability, it remains a key asset in modern mechanized warfare. Loading and firing the M109A7 Paladin is a coordinated process combining automation and crew skill.
Your driver will rev up the gun, the number 1 man will pick up the round, put it on the tray, it goes into the tube, the number 1 man will ram it with a hydraulic rammer. The gunner then will grab propellant, go in the tube behind the round, and then we'll close the breech. Chief will then lay the gun, tell the number 1 man to prime. Once they're primed, he'll tell him to hook up, he hooks up, one last verification, and he tells his number 1 man to stand by and fire.
After firing, the vehicle rapidly displaces to avoid counter-battery fire. Modernization has kept the U.S. military at the forefront of technology and lethality on the battlefield. The U.S. Army's Armored Multipurpose Vehicle, or AMPV, is designed to deliver modern battlefield mobility, protection, and versatility for frontline troops, especially against roadside bombs and underbody blasts, which were common threats in recent conflicts. This increased survivability means soldiers can confidently maneuver in dangerous areas with a higher degree of safety. AMPV's design resembles a Bradley without its turret, emphasizing its support rather than direct combat role. It allows it to serve multiple roles, from mortar carrier to mission command to medical treatment vehicle.
The biggest thing in this highlight is this vehicle comes with 5 variants. You have your mission command, your mortar vehicle, the general purpose, and 2 types of medical vehicles, your medical treatment and your medical evac vehicle. That's one of the advancement. Also the armor protection, the speed, and the survivability system, the upgraded enhancement of the survivability for our soldiers today.
The AMPV must operate alongside the M1 Abrams main battle tank and the M2 Bradley infantry fighting vehicle in the ABCT. This vehicle shows an increased speed and mobility, essential for maintaining pace with the M1 Abrams and M2 Bradley in fast-moving combat scenarios. Live fire exercises are frequently conducted to test how well the AMPV can support Abrams in tight formations without slowing maneuvers or impeding the overall pace of the ABCT, as well as testing other strategies with other vehicles and technologies. This is the case of the 2024 Maneuver Warfighter Conference and its HOTX live fire demonstration, centered on maneuver warfare and innovations in armored combat. Here, military leaders and allied partners can assess how well these vehicles move across complex terrain while responding to simulated enemy fire and explosive threats. There have been new introductions in recent months, such as the AMPV CUAS, which can accurately detect, track, identify, and defeat or disable stationary and moving aerial and ground targets. This constant development of new technologies implemented in military vehicles has been a trend that is reflected in the appearance of renewal programs such as the Next Generation Combat Vehicle, intended to implement a variety of armored vehicles to add new capabilities to Army units and replace existing platforms that are nearing the end of their useful life. Given the emergence of sophisticated enemy systems, including advanced ammunition, anti-tank missiles, and cyber-electromagnetic warfare, the initiative drives the rapid innovation for Army vehicles. These advances are developed in specialized centers such as the U.S. Army Combat Capabilities Development Command Ground Vehicle Systems Center, located at Detroit Arsenal in Michigan. GVSC's mission spans the entire spectrum of vehicle development, from research and initial design to engineering, prototyping, testing, and integration, ensuring ground systems remain at the forefront of technological capabilities. Its mission aligns with the Army's modernization efforts and initiatives such as the NGCV team, which focuses on the rapid development and fielding of advanced combat platforms. From these developments by the NGCV, interesting designs and prototypes have been explored that seek to revolutionize combat methods. One of these includes robotic combat vehicles to offload the most dangerous missions from human soldiers to these autonomous or remotely operated platforms. Currently, the initiative has produced 3 variants, including light, medium, and heavy, that can engage specific mission roles like reconnaissance or direct combat. RCVs can integrate weapon systems, such as anti-tank guided missiles or medium-caliber guns, and even deploy other payloads like electronic warfare systems or counter-unmanned aerial systems technologies. These systems have been tested in several conditions, and the military forces are familiarized with them during events like the RCV Soldier Operational Experiment 2. These experiments provide the essential information to integrate RCV into combat formations, refine tactics, and gather direct feedback from soldiers. Another development that is part of the NGCV portfolio of initiatives is the Mobile Protected Firepower Vehicle. A light tank designed to provide infantry brigade combat teams with a powerful mobile direct fire tool. This is based on the multiple fire support vehicles that have served the military forces, such as the M109 mobile gun system with its capacity to support dismounted infantry and engage the enemy in close combat. This vehicle is part of the Stryker armored fighting vehicle family. It features a 105mm tank gun and a Caterpillar C7 turbo diesel, enabling the vehicle to keep pace with a Stryker brigade combat team and clear opposition quickly to permit rapid movement. Thanks to vehicles of this style, companies such as General Dynamics Land Systems were inspired to design the M10 Booker, an armored vehicle developed from the GDLS Griffin II as the winner of its MPF program. Its development and introduction helped replace the retired M551 Sheridan, a vehicle highly valued for its airdrop capability and support in airborne and light operations. The M10 Booker is armed with a 105mm cannon based on the M35 gun, capable of firing 2 primary munitions. In addition to its main gun, the M10 Booker includes a coaxial machine gun and a heavy machine gun. All of this is protected with modular armor panels for additional protection, and underbody armor shields the crew from improvised explosive devices. In addition to the M10, General Dynamics has invested in developing advanced platforms that take advantage of current technological advances to improve the effectiveness of ground forces. A clear example is the Stryker X and Abrams X vehicles, which implement hybrid powertrains for mobility. The Stryker X is built on the Stryker Infantry Carrier Vehicle platform, with an integrated series hybrid electric power system that provides an extended range for long-distance maneuvers with silent watch and silent movement capabilities for covert operations. On the other hand, the Abrams X is an evolution of the Abrams main battle tank with modifications similar to those applied to the Stryker. However, this vehicle uses a parallel hybrid electric power system that combines the transmission of the Advanced Combat Engine by Cummins and Sapa. The evolution of the military industry, as seen with the development of these new armored vehicles, has demonstrated the change occurring with current combat methods and opened a window to the countless possibilities that this technological innovation will cause for the military forces. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.